so much. Hi everyone. Welcome to today's webinar, delivering safety and reliability through industry collaboration. As Colin said, my name is John Stringer. I'm a principal consultant at Aber Risk Consulting, and I'm also a member of the Safety and Reliability Society's London branch committee, and I'll be your chair for today. So in the spirit of collaboration, this webinar is brought to you in conjunction with the Young Rail Professionals. So on behalf of SARS, I'd like to extend thanks to those involved in helping to bring this event together for you today. Okay, so the railway is made up of many organisations delivering different parts of the railway, but all those parts make up one system. Collaboration is needed to make it work and to ensure it's safe. The Rail Safety and Reliability Standards Board was set up as an independent body to address the need for a system-wide perspective on standards, research, and a range of cross-industry functions. Today, working with its members, RSSB drives improvements in health and well-being and in delivering a safer, more efficient and sustainable rail system. With highlights for safety and reliability, over the next 45 minutes or so, you'll hear from our two speakers about RSSB's work stimulating cross-industry initiatives and projects, maximising data and promoting innovation. Okay, so the programme for today's webinar looks a bit like this. Firstly, I'll just give a brief introduction to SARS and the YRP before I'll introduce you to our two speakers today. We'll then have the presentations followed by a Q&A session. As Colin was mentioning before, we'll have there will be no video during the actual presentations themselves, but we'll have the video on to be able to see me and our speakers during the Q&A. And if I could ask you to use the chat function to type in your messages. If you could use the question, you can flag them as questions. It just helps me to differentiate between those questions and any other chat. So if I could ask you to do that, that would be great. After the Q&A, I'll just finish off by running through a few SARS YRP items before leaving you all to enjoy the rest of the day. Just to let you know, this event is being recorded, including the Q&A via the chat as well, and it will be publicly available after the event. More details about this later, but we'll try and get it up as soon as we can. Okay, so for those of you new to SARS, we aim to be the professional body for safety and reliability and risk management practitioners. The Engineering Council has recently approved SARS as a licensed member, meaning we can now provide our members with a direct path to professional registration for CEng and IEng, as well as providing opportunities for cross-industry learning, CPD and networking. We are internationally recognised as the leading body for domain expertise through our branch technical seminars, journal, knowledge base, webinars like today, and membership. And just a bit about the YRP. YRP is a professional association for young people in the rail industry. Their mission is to promote the rail industry as a great place to work, inspire the next generation of railway talent, and develop and connect the future leaders of the industry. Okay, so now let me introduce you to our two speakers. First speaker is Giulia Lorenzini from RSSB. In her role as Senior Partnerships Manager in RSSB's Research and Development team, Giulia works to support the shared goal of disseminating research, stressing the value of collaborative working and understanding where opportunities to work together might help tackle common problems the industry is facing, much of which is about communication and relationship management. Giulia's presentation will discuss the role of brokering collaboration across industry and academia in order to support rail research and innovation. And then our second speaker is Fotis Zapantis, also from RSSB. In his role as Safety Intelligence Analyst, Fotis helps other analysts build the intuition they need to help to identify safety risk and railway operational incidents. Fotis has experience with diverse areas of operational safety, such as track working safety, intelligence, and train accident risk, as well as asset management for the rail industry and the utility sector. He's also working towards an MSc in Railway Systems Engineering at the University of Birmingham. And Fotis' presentation will provide a deep dive into data science methods for rail safety. Okay, so that's all from me. I'm going to turn my video off now. I'll ask Giulia to turn on your microphone, and I will hand over to you. Thank you. Hope you enjoy.
Thanks, John, and thank you everyone for joining us for today's webinar. I hope you're all well despite the current situation. As John mentioned, we're here today to talk about delivering a reliable and safe railway through industry collaboration. Clearly, because of my role, I'll be focusing more on the reliability and collaboration aspects, and I'll leave Fotis to focus on the safety angle. So just to get us started, in order to understand rail, we need to recognize that the rail industry is a complex system. And as a complex system is made up by many different components, coupled together, interacting amongst each other, often in a non-linear way, trying to always adapt and learn in response to change. So the mission to deliver reliability in a complex system like rail is to ensure that all the different subsystems are working together to achieve the right objectives. And that's why for this, we need a whole system approach, which takes into consideration not only the different technical subsystems, but also looks at the interfaces between the subsystems, the passengers, the human behaviors, and so on. And only by applying a whole system approach, then we can achieve higher reliability at a lower cost than if we were taking a more silo approach. And that's where RSSB roles comes in. RSSB role is here to help the industry deal with this complexity through our R&D program, through the safety work that we do, through our standards, which are our key main functions. So in a complex system such as rail, there are also complex challenges, and probably one of the reasons why we haven't quite been able to fully tackle them yet. And these challenges clearly exist in an ever-evolving environment. I'm talking about things like increased passenger numbers, complex timetables, restricted maintenance opportunities, and all of these under a very demanding public pressure to deliver. Now, all of these, although you can argue could possibly be turned into opportunities, may lead many people, including Keith Williams, to think and to say that the rail industry may no longer have the same ability or the same incentives to innovate as potentially other industry have. And this is actually being reflected in a sector pulse that the RIA and Network Rail launched late last year in November 2019, where about pretty much almost 100% of the respondents said that they found rail hardly or quite innovative. However, I think it's also worthwhile saying that it is the race to continuously deliver and trying to deliver more value that is what forces industry to innovate, in some cases at a faster and some other cases at a slower pace. Look, for example, at the automotive industry, at the energy sector, or as more recent news have shown us, even the space sector. There is no doubt, I agree, that there is definitely more that we can do, and still a long way to go for the rail industry. However, at the same time, I think there are quite a lot already happening, and that we need to recognize that. So, for example, if we look at augmented reality, for example, Keolis is using smart glasses, so that staff that goes out in the field can send images back to their headquarters to be analyzed, for example, or thermal and visual imaging equipment that, for example, are available on Network Rail helicopters, so that the maintenance teams can go out, cover large areas, identify faults, almost with sort of remote condition monitoring type equipment. Digital twin, it's true, is probably a bit of a buzzword at the moment, but they've been used, for example, on the Crossrail Elizabeth line, which uses digital twin to simulate physical assets, facilities, etc., and to sort of check what the system is doing and monitor what it's doing in real time. But more recently, even Greater Anglia has been working with Toshiba to use digital twin to improve timetables, specifically on the route from Liverpool Street to Cambridge, to understand how they can actually perform in real time and see how they can improve that in real time. If we look at the Internet of Things, for example, that's already showing us the power of connecting, the power of integrating data, which again could have many, many different benefits. For example, it could lead talks and the industry as a whole to understand passenger profiles better, to understand their behaviors even better. So I think amongst all the challenges, the real focus and the real challenge for rail should be to realize the potential from various different technologies, and especially from data, of which rail is really rich. But the tricky element is to understand how we can make better value from all the data that we collect. So, in terms of bringing it back to reliability, from my experience, from the work that I've been involved in, what I would say is that in order to support reliability in a complex system like rail, I feel that there are three main pillars. There may be many others, but these three are the ones that I think are definitely fundamental to the discussion. Investment is definitely needed to improve the system infrastructure. Collaboration is needed to fulfill the industry's full potential. And this really comes across from the work that we do at RSSB, across all departments, really. We work to help industry tackle current issues, current challenges, but these cannot be done in isolation. And that's why we work with our members across the industry to collectively use cross-industry research, innovation, expertise, especially to develop that knowledge, to develop technologies, and even operational solutions that could then reflect back and improve the reliability of the whole system. So if we look at these three pillars, elements, one by one, in terms of investment, what I can definitely say is that as far as I'm aware, investment opportunities to stimulate innovation and build a more reliable railway are definitely out there, and there are many. I've only listed a few, but if we look, for example, from a low technology readiness level scale at the research and development competitions that we do at RSSB, the opportunities that are coming across different research councils like EPSSC, for example, and others, the opportunities that come, talking about now a higher TRL level from Innovate UK, first of a kind opportunities, but also at the innovation and funding that is available through suppliers and also through networks like Ukraine. There are also, and rail, I think, is great at that, and today is definitely testament to it. There are lots of networking opportunities. The Rail Innovation Network was quite a recent forum, is engaging rail with tech startups, which I think is a great opportunity for us all. We then have the catapults that clearly promote a more cross-sector fertilization, but along those, clearly there are many others that can be added to the list. Now, in terms of mindset, from my experience, again, I think that in rail, too often there is too much focus on the immediate issues and almost always wanting solutions that they should have been ready yesterday, kind of thing, and not enough planning to make the future better. And of course, when we look at the future, everything will look more uncertain, more risky, may require more investment. And that's why I think in order to change this culture, in order to change the industry mindset, we need to have a strategy pitched at the right level, one that can be achievable and one that people can actually buy in. And that's why at RSSB, but also in collaboration with Network Rail and colleagues from Ukraine, we are revamping the rail technical strategy. Some of you may remember the previous version that we drafted in 2012, but what this strategy is key for, and I think that's why it will help changing the mindset, is because it's more focused, it provides more clarity on what really the key problems are, but it's also more compelling in the sense that it provides not only the very far away objectives, far in the future, like the previous strategy may have done, but it also provides what achievement needs to be ticked off in the short term as well. And the other point that I would make in terms of strategy that achieve us to change mindset and therefore achieve higher reliability is that need to be driven by business needs, but also have a greater ownership by the leaders that are behind this. And the third point, clearly collaboration, which is what we're discussing also today. Again, to achieve the strategy and to make rail more reliable, collaboration is absolutely vital. In my role, I've been managing, supporting and leading some of the collaborations that at RSSB we have, and that really span across a wide range of partners. We work with international partners like TRI in Japan, or SNCF in France, or Trenitalia, where we do more of a knowledge sharing sort of exchange. We work very closely with academia. We have strategic partnerships set up with the University of Huddersfield, where we look at more specific challenges, and in particular with Huddersfield, we're looking at risk and safety. With Sheffield, I'm mainly working with them on the adhesion and tribology areas, and with Leeds, we're looking at rail economics, for example. We are a funding partner as well as of Ukraine, which is a cross-industry collaboration to support RD&I. But of course, duty holders are the main partners for RSSB. Not only they are members, but they are the leading force really for all our work and the people that can actually implement the work that we do. RSSB through R&D, but also other departments, we work across the suppliers, the supply chain as well, with small, medium and large organizations, but also other industry bodies, research councils, government bodies, and of course, professional institutions like SARS, IMECI, ICE, and so on. But collaboration is not only about the whom is involved, but also is about the what. The list that you see here is by no means exhaustive. It's just a selection of some of the topics that RSSB is working on and some of the topics that I had the pleasure to work on personally. So just to give you a flavor of the type of collaboration that we do, we've applied research to improving rail adhesion, working with Sheffield, Huddersfield University and many other companies. We are working on network performance, and I'll touch on that in a little while. We're doing work on air quality, decarbonisation, working with lots of SMEs and innovators, looking at different ways of potentially powering trains, reducing the carbon footprint, etc. In recent months, groundbreaking research has been done also to improve train design in terms of the characteristics of seat comforts, and we've also worked on trying to find technologies basically to improve reliability using robotics applied to train maintenance, for example. The RSSB drive in a way to push on collaboration, which is the backbone of what we do, and not only collaboration but also innovation, has definitely been seen through lots of the R&D and innovation competitions that we've launched in the last couple of years, which I've been working on, and some of the topics that you see on the slide now are where the scope of some of these competitions. And these initiatives really aims to stimulate businesses, academia, innovators, suppliers, duty holders to really come together, bid for funding to develop ideas which we hope would make a difference for the UK railways, and at the same time clearly increase reliabilities. But for this to work, clearly, going back to the point, is that it's down to the industry to work collaboratively, to identify the investment that is required, the right expertise that should be involved, which more often than not are multidisciplinary, but also to share data. And in terms of data, I think that this is really the common denominator for this topic and many other things that we're working on at RSSB. Data really brings organization together, and I'll give you an example in a minute. Even brings together those organizations who would normally be competitors, but they see the greater good in sharing the data, in understanding the problems better by doing so. And therefore, data become not only the goal to actually collaborate with someone, but the mean to forge new collaborations. It becomes almost like a currency through which people and organization come together. So to give a more practical example, as you probably are aware, in the last couple of years, network performance has been declining, meaning that passengers clearly were more and more dissatisfied, that were losing trust in the system, and therefore reliability was not met. And that's why I was going to use the Data Sandbox initiative as a good example of how successful collaboration could make rail more reliable. So the Sandbox initiative was initiated in 2017, where I pretty much put together a repository of data samples from across the industry, which is still available in case you're interested. And because we saw the interest that people started to have for research purposes and other reasons in this repository, we decided to put some investment on the table, and we launched a competition, which saw really interesting ideas coming from 5 academic leads who worked together with 5 different train operators and Network Rail. The results that we had were really promising, and we decided to go on with a stage 2 last year. The interest was ever so increased, and so Network Rail decided to join forces. So we had even a greater pot of money, basically, to make available. And the scope of this collaboration clearly was not only to understand industry data better, but was clearly also to improve network performance, understand why variation exists when we look at, for example, dwell time, why we have reactionary delays, how can we make the system more reliable, basically, using data. These will, of course, lead to operational savings, both from an operator point of view and Network Rail, but also fundamentally improve the customer experience, which is key to improve reliability. So this example, I think, explains quite well the 3 pillars that I was mentioning before. In terms of investment, we had some investment put up front with both competitions. I acted almost as a broker to forge collaborations between different organizations and to find the partners that should work together. And all of these brought quite proudly to a significant change in mindset in terms of colleagues from performance teams, both at the operators level and at Network Rail, to see things slightly differently and understanding that there are new data analytic techniques, being machine learning, being AI, and many, many other different techniques that could actually provide really, really useful insights in what they do and in how we can do that better. I was going to touch on 2 case studies, but I know that we're running out of time. So the 2 case studies were really only aimed to just to explain how collaboration, for example, in this case between Roscoe, Porterbrook, an SME like ElastaCloud and University and TOX, and the availability of data brought to the ability to actually draw some conclusion and correlation between those data and some of the sub-threshold delays and therefore cost that, in this case, the operator was experiencing. And the second case study, very similarly, enabled us to work together across the board between Network Rail and operators to produce different models, to produce different scenarios in order to improve the way that the performance is dealt with. So in conclusion, the message that I want to leave, and it's really more of a food for thought than anything else, is that leveraging, I guess, the data that the rail collects is key to improve the running of the railway, to improve customer experience, and to deliver reliability. The key must be on focusing and improving the quality of the data, making it more open, making it more transparent. The opportunity that we get is clearly that data triggers more investment, that it promotes a culture change, and therefore becomes almost a goal, like I was saying earlier, and a mean to develop new collaborations, which shouldn't be of the fluffy type, if you allow, but they must be absolutely clear on commitments if we want rail to be the mode of choice, to deliver for passengers, to deliver for freight, to be cost effective, to be safer, and to also be more reliable. And on this note, I'll pass it on to Fotis.
Thank you very much, Giulia. I'm not sure how I'll manage to keep everyone's attention after your very interesting presentation, but I'll try to. So to begin with, I've got a slide about me. Most of that has already been mentioned by John. I just wanted to note the fact that I'm also a mentor for the Women in Rail Cross-Industry Mentoring Scheme. That's a very important scheme that started back in February. So please do have a look. There is a progress of update event tomorrow, and I'm more than happy to provide more information about it. I've also got some of my social details, web social details that is, and in a sentence or in a word, if I wanted to describe my day job, that's more or less playing music with safety data. As Giulia mentioned, data is almost like a collaboration currency, and this is how we are trying to see it, and this is how we deal with it at RSSB. The four fundamental properties that data has, or data is being described with, is its veracity. So by veracity, we usually mean the degree to which it is accurate, it is precise, and it is trusted. It's not the easiest job in the world to provide and to process data that's certain and reliable. And this is something that we strive for at RSSB with a big data quality stream. A second dimension is the volume, the sheer volume of data. You can see a few of the reporting systems that we have in operation. This is the Safety Management Intelligence System, the close call database, R2 rolling stock database, CIRAS, which is the confidential reporting part of RSSB, NIR Online, which is the National Incident Reporting System, and then a few risk models which cover a lot of that, and some data sharing with other organizations. The sheer volume of those data sets and the speed at which they move makes it quite complex to collect and to steward. So I've briefly touched upon the velocity and the variety as well. I just wanted to mention those things because it's quite a tedious job to maintain those systems and maintain them in a way that they provide accurate information that can lead to active collaboration, as Giulia mentioned before, and not just collaboration by name. If anyone is more interested, there is a customer portal service, and you can also get access to the data for business purposes or for research purposes. I think the only caveat is that you might need to be a member or an employee of a member company, but by any means, try it first. So regarding how our main job and our main product is the estimation of safety risk. So this is the risk from the operation of the railway arising from various incidents that might happen in a railway operational environment. Our key model, or our main tool to do this job, is the safety risk model. This estimates the underlying risk from the operation and the maintenance of the mainline railway. It comprises of a series of models which represent what we say hazardous event, or a dangerous situation, a situation with potential to cause harm to either the workforce, the passenger, or members of the public. RSSB uses this model to produce the risk estimates for around 131 hazardous events at the moment, and almost 3,000 event precursors. That's the incidents that might lead to a hazardous event. The SRM measures risk in terms of frequency. So for lovers of risk, risk is frequency times consequence. A consequence for us is the expected level of harm that arises when it does. And we usually measure that in what we call FWI, or fatalities and weighted injuries. This adds up weights to what we consider statistically equivalent harm. So one fatality is equivalent to 10 major injuries or more class of lower harm events. I'm not going to go too much into that because there's a lot of detail, but the main point is to consider is that this model is a spectrum from high frequency events, so events that happen often but usually have low consequences, so they don't lead to harm to people, public, or workforce. And then we have these rare events, or what in other terms might be called black swan, that come every now and then. And we don't always have very accurate models about those things. As a next, so yeah, this is the next one. So as a next one, I would like to describe a little bit the tasks or the methods that we use to classify and label all these incidents. Most of our methods are based on data mining. Data mining, although it has come back with a great hype in terms of machine learning, artificial intelligence in its spaces, and in its theory and science, is actually ancient methods, or methods that have been around for quite a while. Maybe the implementations have recently changed or might have recently evolved, but the main bits and pieces are classification, the regression, the attribute importance, detecting anomalies, associating different incidents or different buckets of incidents, selecting features and extracting the relevant information, and clustering the relevant information. This is more or less what exists in anything that constitutes a modern data mining toolkit. And the reason behind using this standardized methodology and the standard methods is because the analyst, as a person, might have bias and might have some cognitive bias, some ideas about when and how data happens that might not be objective. And this is a way to objectify the opinion and to neutralize the language behind causal attribution, or behind trying to explain an event or a series of events. Yeah, so moving on to the next slides, what I term as data science method today is to try and make data actionable. So use any tool you can find out there to extract as much information as the data contains. And that comprises of mathematics, of logic, of algorithms, and usually some assumptions about the uncertainty underlying the data set. One can easily understand that this is more like a life cycle. So it is a life cycle with different phases. And we've tried to identify where the sweet spot is for us. So where the business problem is not too difficult to model, in which case we could go on forever but never really achieve something. And where the analytics is also traceable and can happen in an amount of time that, like, it won't take forever to get a result. And we've classed those three types of actionable intelligence as hindsight, insight, and foresight, which can be seen in a spectrum. So hindsight really answers the questions of what happened. The insight answers the question of why, that, or the causal attribution. And a third bucket could be what will happen in the future, and how we could predict the future with the data that we have today. As you might imagine, there's a lot of uncertainty. So if I only take the current situation into account, I don't think that the data we have could actually predict a pandemic. But this is what happened, and we need to quickly be able to model the situation and infer rather than deduce solution. From a theory perspective, I've just found a very good reference from risk analysis. So there's not just one way to describe and model those events, which is the usual event trees or fault trees, which most safety and reliability professionals are accustomed to. But there are a lot of other handlings of the formulation of what constitutes a complex system, but this is more of an academic discussion. So I'll just move quickly on to a case study. So my first case study is the treatment of disabled passengers. That lies more into the bucket that tries to understand the causal attribution. So in order to process the data in a way that is reproducible, so it can be reproduced by another researcher, we used the Python programming language via the Orange data mining package. This is actually quite simple to use package. It's an open source tool for data mining and machine learning, and has been around for about 23 years, just to mention that. We used a graph inference model, a POL model. This is quite popular in the investigation literature. So it involves analyzing your key data set in a person, an object, location, and an event type of interaction. You can see some of the entities that we identified through what we called natural language processing, or through going through about 1,500 records. And just to point out how to achieve the actionable intelligence, I'm just mentioning a few of the safety insights that were the result of that work. So for disabled passengers, so disabled might imply reduced mobility and many other categories. The process of booking assistance and the experience with the assistance staff is a major concern, and a hypothetical action is to provide some different ticketing arrangement for those passengers. For example, day tickets. I'm saying hypothetical because that's not something that necessarily can happen in a way that's easy to justify the cost, but I'm just showing here how the data leads to an actual insight. So the second insight that came out of this work is that disabled toilets are usually used by non-disabled passengers, and the general level of cleanliness is not very well perceived. Again, a hypothetical action would be to not allow access to those locations to non-disabled passengers. And the third one, which was also quite interesting, is that disabled passengers usually suffer from upper body injury, so shoulder or knee or neck. That's also a direct consequence from the fact that they might, in cases, be at a lower level than normal passengers. And a hypothetical action is to try and segregate the two passenger flows. Of course, maybe an action that might not be as easy to implement in reality, but it's quite interesting that it has also come up from other types of research, such as surveys and logic models in literature as well. And quickly go to the second study case that was on track worker safety. There were recent accidents that sharpened the focus on the area, and we helped Network Rail analyze the various data sources which I mentioned before, such as the investigation reports, the near misses. So near miss incident is an incident that didn't necessarily lead to harm, but it had the potential to do so. And in this case, and what I also wanted to state very, very clearly, is that although we did have a data set upon which to work on, there's a lot more work required for us to manage to get to something that's very clear statistically and very, very actionable. And that was something that we agreed to do in the future. And on that point, I'll just briefly mention a correlation between operational incidents, so incidents that happened on the railway, and higher temperatures. So it looks as if we get more such incidents in higher temperatures. But if you look that side by side with when the work is happening, someone might go back and say that the causal attribution, so it's not necessarily a causal factor for the incident, but it's something that has to do with when work is taking place. And just to quickly wrap this up and give an understanding of the feedback loop. So what we understood as success criteria for those cycles, for those data insight cycle, is to try and focus on what the area with the business value is. Start by something that's small and manageable rather than something that's big and very, very complicated. And work in hypothesis-driven cycles. That's what we call the Agile Sprint, which is a very, very good way to justify the effort and document the findings and the different contributions as well. I'll also say a couple of things on the things that didn't go so well. So just being fascinated with the hype or with the technology is not enough. Definitely, it can provide solutions to questions, but it can also lead to inability to show the added value from the business perspective, and something someone would like to avoid. Usually people have an unrealistic image of what data is available and how easy it is to merge them. So there are a few overblown expectations there. And sometimes people don't necessarily understand what the methods can do. So I think I stated that quite clearly in terms of removing the cognitive bias behind analysts and behind what they think. But the experience and the domain knowledge are things that are not necessarily replaceable by a data system. That's why, as I've stated in the beginning, it's an opportunity for collaboration and an opportunity to open questions that someone would otherwise not be able to open. And with that, I open the up into the floor for questions. I think now it's time. So happy to take any questions.
Thank you, Fotis. Thank you, Giulia, for those presentations. Could I ask you both to turn on your video, please, for the Q&A? That's all right. Thanks, Fotis. Are you there, Giulia? Excellent. Thank you. I can see that there's been some questions already that are coming through the chat. So I will take a couple of those first off, and just to say, if anyone else has got any other questions, just put them through. If you can flag them, and I will do my best to get through them and ask our two speakers for their thoughts on those. So I think we'll start off with, well, the first one that actually came through is from Giant Pandy. It was Giulia, you mentioned digital twin model. I think it was just a question around what is a digital twin and how is that used, and in terms of the liability and collaboration you were talking about.
Right. I'll start saying I'm not an expert on digital twins, so don't expect a super technical answer. But what I can say is that there are different interpretations of digital twins. I guess the easiest one is a simulation of real assets in a way where data gets combined, and in a way where you can actually get more insights from the wealth of data that you stitch together. So it's been used, for example, I was mentioning the Crossrail, the Crossrail Elizabeth line as one. It's been used by Greater Anglia and Toshiba to simulate the line from Liverpool Street to Cambridge. It's currently being used by another project actually within the Data Sandbox initiative to simulate King's Cross Station and pretty much understand passenger movement, understand what implication those will have. I think it's probably worth saying on digital twins that although they are a bit of a buzzword, like I said, a bit of a, everyone is doing digital twins at the moment, there are definitely many benefits, and the main one is the fact that they help us as an industry understand our data better and correlate data better. But there are some challenges in there as well. First of all is, I guess, identifying the right data to use. And secondly, it kind of opens up if you want, the attack surface. So there could be more cybersecurity issues involved. We have actually we have a useful blog series on the RSSB website if you want to if you want to have a look.
Thank you. Thanks. Fotis, anything you want to add on that?
Yeah, I'm not sure I'm a digital twin expert either, but I would say that in terms of optimizing processes, sometimes some types of process automation can happen online compared to offline. So you train an algorithm and the algorithm can immediately correct non-compliances and points where faults are starting to emerge. So definitely something to look at.
Okay, thanks. Next one is from it's actually from Colin. Says, is there? I think it's aimed at Fotis initially. Is there good collaboration in the collection of reliability data in the industry? Actually, that's probably to both of you, but I'll go to Fotis first.
Right. So I work in a different area. So I mostly have to do with safety data. I'm not sure about reliability data. What I can say from trying to get data from the ORR data portal, for example, that's a very, very good source of information, is that I managed to find very good quality information at a quite disaggregate level, which I managed to use for my own analysis. So I'd say from my experience, yeah.
Okay, Giulia?
I guess it would be worth splitting the questions in two. So one is there good collaboration in the collection of data, and is that data then reliable? So as far as I've been involved in data projects and data collection and setting up the data sandbox itself, the collaboration is there. It's not always easy, and that's mainly because of commercial sensitivities, clearly. There are lots of initiatives out there that are trying to promote a more open sharing of data. This topic was very much part of the rail sector deal that was discussed a couple of months ago. So the industry is well aware of the challenges, but I think we are doing we are starting to do a good job in terms of collecting data and collaborating to do that. Data Sandbox is definitely one example. Network Rail has a huge program called Enrich, which is trying to achieve the same thing. The Data Council has been set up as a cross-industry initiative to actually give incentives to different organizations to do that. And one of these incentives is actually to train and to get almost data champions in each organization that can promote the open sharing of data, which, however, we always have some constraints at the end of the day.
Okay, thank you. The next question comes from Laura Reardon. Says, could you expand on the data quality program mentioned with regards to data veracity? Fotis.
Yeah. So it's not it's not 100% my area of expertise, but I do often interface with a team. Data quality is a very important part of the whole data science effort. So most people agree that this is actually 80% of the effort required to reach a data product. It's about cleansing, it's about processing, it's about making sure that your data set is correct. And I can also add that when you're using different systems or systems that were not necessarily designed to cooperate or work together, that might take even more time. But there are measures, so there are things that can be measured around data quality, and there is progress that can be measured around data quality, and I think these are the main efforts at the moment in terms of how to integrate and how to measure.
Okay, thank you. And Julia, do you want to add anything, or was that?
Nothing to add.
Nothing to add. Okay, and we possibly probably only got time for one more before I could do the final bits. But this one's from Febi Joanne Subriadi asks, what measures can be taken to ensure filter data from others are accurate?
Giulia, do you want to start?
Yeah, it's hard. So it goes back to is data reliable, basically, and it's hard to determine that. I guess there are measures that can be put in place in terms of ensuring quality, ensuring that we get what we need. And one thing that I've noticed in all the dozens of data projects that I've been working on, I'm currently working on, is exactly the issue of data quality. Data tends to be, especially if we look, for example, at OTMR data, it gets stored, it gets downloaded from different train companies many different ways. Some train operating companies use a system called Nexala, which sort of creates a specific download of the data in a specific format. Other train operators don't, and like that, many other types of data. So it's a matter, I guess, of streamlining the quality of the data. So it's very much what the Data Council, the cross-industry group that I mentioned earlier, what they are trying to do, because there's clearly nothing that we can impose each organization to do. But I guess it's indirectly a call on to all the organization that collects data and have data to try and understand which way would be best to collect it in order for it to then yield even more values going forward when it's matched with other data.
Thanks. Fotis, last words.
So just a couple of last words on that. So for me, that also goes back to the design of the experiment. So whenever you're dealing with a data set, essentially you collect or you extract a data set to try and answer a question. In order to, if you want to quantify how well you achieved that, I think that the best question you can ask or the best way to ensure this is to design your experiment properly and understand the question properly so that you can get an answer from the data that you're looking at.
Excellent. Okay. Thanks for that. I mean, there's no other questions on the chat. I'm just looking at the time. We've only got a few minutes left before 2 o'clock. So I'll just say thank you to both of you, to Giulia and to Fotis for your presentations. Certainly very interesting for me as a safety and reliability professional, and hopefully to everybody watching. So thank you very much. I'll just run through a few final slides. Oh, sorry, Colin. Thanks. Just before everybody goes, just a bit about SARS to start off with. I say some of you on here, we've got members and non-members. We accept. If you're not a member, please do sign up. We also have an associate member now, which we can offer, as well as obviously the C-Eng and I-Eng membership. So for all membership applications and things, and so to access other webinars and other information, please have a look at our website for that. We've got some upcoming webinars. The next one is on the 17th of June. It's the basics of risk management. This is number 5 in the series of basics of risk management that we're running. So again, please check out the website for that one. I think there's some YRP events coming up, most notably this rail quiz night on the 10th of June, hosted by Pete Waterman, which sounds like it should be quite a fun event. They've also got a number of webinars available on their YouTube channel, and so please take the time to go and have a look at that and visit the website if you're interested in in any of the other upcoming events that they are running as well. And lastly, just to say, well, actually, that after this is finished, we're going to initiate some feedback forms. If I could ask you to fill those in before you exit the webinar. I mean, this helps us to kind of improve future webinars, so that you know, we can give you the best experience we can going forward. It doesn't take long at all. So if you could fill that in, that would be much appreciated. And the what I forgot to mention was that the webinar itself, so it's been recorded. It will be freely available. Will be accessed on the via the SARS website, and also through YRP as well. We will try and get that up as soon as we can, and get details out to you, so you can access that at any time. And say check out ours and YRP's social media, and follow us for information on upcoming